Hey everyone, and welcome back to D'Angelo's Woodcraft. Today I'm going to be making some backgammon boards that required probably the most delicate of touch I've had to deal with, but that was kind of the point, as I really wanted to make something one could call intricate. I was originally motivated to make these for a friend of my dad's, and that wound up paying off as he purchased the cherry and maple board right after I sent him the listing. However, the Padauk, maple, and brass board are up on my Etsy as of the time of posting this video, and I will link that in the description. I started off with some milling, and these boards actually didn't require all that much material, but the material I did use required a lot of work and, like I've already said, a very delicate touch. The first steps I took were to build the frames. In case it wasn't clear, I'll be building two different boards throughout this video. Both are primarily walnut, but the accent pieces were different, with one of them using cherry and maple, and the other using Padauk and maple for the points and brass for the trim. I wound up really liking the Padauk and maple a lot more, so you'll primarily see me working on that. Here, I'm just setting up my table saw to cut a 1/4 inch rabbet on my frame pieces, as this is where the top and bottom panels will go in later. I don't have a dado stack, so just about every rabbet or groove I cut is done in multiple passes with a flat top grind blade. I would love a dado stack eventually, but it's just not in the budget right now. Speaking of budget, let's talk about how I've been able to build up my shop over the past 2 years. I mentioned this in my chessboard video that I worked at a rockler for a while, which was really helpful for keeping costs down, but even then, my best resource for finding good, or even just decent tools at a lower cost has been Facebook Marketplace. The table saw you see me using right now is a Rigid TS3650. It's an older model. I think they were last produced around when I was born, in 1998. But I believe it's one of the last that came with full cast iron wings, and I was able to grab this for only $250. It did require a little cleanup and whatnot, but that's relatively easy, and for the price, it was definitely worth it. This thing's been a workhorse for me. So now that I've prepped the pieces for the frame, I'm setting up the saw to cut miters at 45 degrees. And I didn't really trust this digital angle finder, so I just took the rule out of my combo square and used that instead. Now you'll see me setting up a stop block on the table saw fence, and I highly recommend this to anyone making a box of any kind, but specifically a mitered box. This is because in order to get a mitered box with tight joints and that is square, two things are critical. One being miters that mate to form a perfect 90-degree angle. The main reason my picture frame sled works so well is not because each piece is cut to form a perfect 45, but actually that the sled forms a perfect 90 between the two sides. And two, the pieces that run parallel to each other must be the exact same length. If either isn't right, you will either get gaps where the pieces meet or a box that is out of square. The next step was to cut up some thin stock for the dividers that will hold the checkers and die neatly in the board. I recently picked up this thin rip jig from Amazon for this project. I'll link the description below. It's pretty accurate and I enjoyed using it. You definitely don't want to make super thin cuts on the inside of the blade for both the sake of accuracy and safety. And once those were cut up, I gave them a little sand to get rid of the blade marks, and then I could use my flat top grind blade to make some dados. You'll probably want to cut down your stock first so that you can reference that, then you can cut your dados. You see me making some marks here, and those correspond to the size of checker I'm using. I hadn't purchased or made the checkers at this point, but I definitely recommend doing so if you're going to copy my build. Because I didn't, my checkers wound up a little too loose in there for my liking. These are the initial cuts, and then I snuck up on the divider width until it fit nice and snug. Now I'm going to cut 2 more dados, but just on the frame piece for now. If you're wondering how I'm getting the measurements for any of this, it's actually all based on checker size, diameter, and width. I modeled this whole design in Fusion 360 beforehand. Some people might call this overkill, but I find it makes the entire build process so much more straightforward, which saves me time and money, and I end up with a better end product as a result. I'm using some blue tape here to temporarily hold the box together while I fit the dividers. I emphasize the importance of sneaking up on your cut here, instead of solely relying on measurements. And once that's in place, I can make some markings for the dados on this divider. This section is where the die will go. Now, I just want to give you a quick reminder, if you're liking the video, consider giving it a like and subscribing to the channel. This is a huge gesture for me and is absolutely necessary to getting this channel off the ground. I really appreciate those that do. Thank you. And now that those dados are cut, I just need to cut some little divider pieces to go in them. Once everything's cut to size, I went ahead and sanded all the interior surfaces before the glue up, as it's the only time I'm really going to have any good access to them. I used my festival sander for the rougher grits, then used a block to sand with the grain at 180 grit. Then I used some blue tape to protect those surfaces before I apply the glue. This can take a while, but I've found it's really helpful for keeping your surfaces looking their best, particularly in hard to sand areas. I've found that for best results, you want to clean up the glue squeeze out right away, then remove the tape right after. If you wait for the glue to fully dry, the tape then sticks to it and makes for a very difficult removal process. I created these kind of templates earlier in the process to get the size of my original box pieces, but here I'm using them as a backer to get the divider to sit flush with the rest of the rabbets. I also put a little packing tape where glue would be touching the template so it wouldn't get stuck in there. With the frames out of the way, I cut down this 1/4 inch A1 grade walnut plywood, which is the highest grade you can get. I think I showed me using setup blocks for the depth of the inner rabbets of the box, but in actuality, I used the thickness of this panel as almost every type of plywood is actually thinner than the marketed value. Once those fit in the frame nice and snug, I traced out what will be the playable area of the board so I can make some reference lines for the points/triangles. Again, my 3D model was used as a reference for the general spacing of these. Now I'm ripping down some Padauk and hard maple for the inlays that will form the points. I did a fair amount of research, aka watching other YouTube videos of backgammon board builds, and thought this would be the best way to put a bit more luxury into mine. One video I saw used veneer for the points, which would probably have been a bit easier, but I didn't like the idea of the veneered points sitting slightly higher than the rest of the board. I'm happy I did it this way, but man, it was a shit ton more work. Here, I'm cutting the points using that angled piece on my crosscut sled. To do this efficiently, I attached my thin stock together with some double-sided tape. Then, I cut it a bit shorter to fit in the limited space, and used a scrap I cut to size to roughly guide how far I need to cut down on that angle. Once those were all cut up, which by the way took a lot longer than you'd think, I could go ahead and line them up on the board. I used a thin double-sided scotch tape to hold them down so I could then mark out the perimeter of each with my marking knife. Then I used a spiral downcut bit on my router to remove the bulk of the material. Because this is a plywood, the veneer was likely to have a lot of tear out. Using a downcut bit prevents this. While routing this out, I made sure to get close to my marking knife line, but not too close. This makes it easier to get a nice clean line with the chisel. One of the more challenging parts of removing this material was at the fine point. Using an X-Acto knife, I deepened my marking knife cuts, then used a painter's palette knife to remove the point. I also used a smaller chisel to clean that up a bit more, being very careful not to accidentally damage the surrounding area. That painter's palette knife I mentioned before needed a little bit of work done to it to get it to work for my needs. I flattened the back of my diamond stone, then gave it a double bevel so it could cut into and pry up that material in the point. I want to take a second here to discuss the adhesive I'm using to get these inlays in. I actually did a whole trial run testing wood glue and 2 different types of 5-minute epoxy, one of them being JB Weld and the other being Starbond. At the end of the day, I opted for an epoxy as it was significantly better at gap filling than any type of wood glue. But you might be wondering why I tried 2 different brands of epoxy. I'll reiterate for my chessboard video, I have no sponsorships. Yet. I'm just sharing a product that I found worked really well. That product being the Starbond 5-minute epoxy. I had used the JB Weld clear weld that's readily available at your local home center in the past, and always been disappointed with the cure time. The manufacturer says it's supposed to be cured in an hour, but while I was making my chessboards, I would come back close to 24 hours later only to find it still tacky. On the other hand, the Starbond was workable and not tacky in just 8 to 10 minutes every time. If you're looking for a good 5-minute epoxy, I definitely recommend the Starbond, and I'll link it in the description. Now, I named this video what I did because all my past projects have been kind of bulky. Thicker stock, materials that don't require much of a delicate touch. This whole project was meant to be thin and intricate, but there was nothing that took more of a delicate touch than this walnut ply. You saw me doing a little repair there a few moments ago, and that was because I sanded through the veneer. Something I opted not to show too much of in this video, but a recurring theme for me that led to a fair amount of suffering. That repair actually didn't wind up making it into the final project, as I finished a full board phase only to sand through the frickin' veneer and not have a good way to repair it. This walnut ply absolutely sucked to work with. I would absolutely not recommend using this if you're going to copy this build, and instead go with a thin hardwood panel. Believe me, it will save you a lot of headaches. Of course, you're probably going to need a drum sander to make one, but another thought I had was to make my own veneered MDF panels. But this would also require a drum sander and or good quality bandsaw, both of which are just not in the budget for me right now. Anyways, here's a time lapse of me doing a half board. For reference, each half board usually took me around 2 hours of straight work, with 2 breaks of 10 minutes each to let the epoxy dry before I could plane it down. Even after doing this a few times, I just couldn't get it down under that 2-hour mark, meaning this portion took me at least 8 hours of doing these inlays per complete backgammon board. Once I had hand sanded these, emphasis on hand sanded unless you want to go straight through the veneer, I put a coat of finish on them to protect them right away. This was definitely the most difficult part of the build, so having these panels done was really exciting, and now I could move on to the splines. I'm using my spline jig here to cut the recesses. Cutting these recesses was the same for both boards, but there were some pretty significant differences between the 2 boards because in one, the splines were wood, while in the other they were metal. Because this cherry and maple had a kind of boring, more reserved look, I decided to install them in a mirror-like pattern, with a piece of cherry and maple in one corner, then mismatched in the next. Once that glue had dried, I could flush trim those splines and sand them on the benchtop belt sander. I picked up this rigid tabletop belt sander a little while back and was super underwhelmed with the dust collection. Not only does poor dust collection pose a threat to your lung health, but it also leads to a huge mess of dust on the tool that can impact your accuracy and workflow. I couldn't find any good solutions online, so instead I picked up a cheap 3D printer to create something to resolve this. That little dust port you saw in the previous clip is what I came up with. It works really well, is super easy to install using the stock thumb screw, and although it's intended to be used with standard 2.5-inch flex hose, I also created these adapters that can plug right into standard vacuum hose sizes. I sell these on my Etsy, which I'll link at the top of the description, but other than subscribing to my channel and liking this video, picking one of these up is probably one of the best ways you can support me. So head on over there, I guarantee you'll be happy with this upgrade. You saw me putting a 1/4 inch round over on the edges of the frame. I had already completed the cherry and maple board and done the same, and really liked the look, but doing this with metal was going to pose some new challenges. In my chessboard video, I showed the arduous task of sanding and polishing the brass once it had already been installed. What I didn't like about doing it that way was that there were still some small scratches that were really difficult to get out due to the nature of the process. Because of this, I wanted to try a new method here where I fully finish the metal and then install it. This was going to enable me to sand and polish everything much better, as I wasn't having to worry about the surrounding wood. But because I chose to do a round over on the edge, I also needed to do a bit more complex shaping of these brass splines. I picked up some 1/8 inch flat bar steel to create a template for the shape of the spline recess. I could then use that template as a guide to shape the brass with a file. I had to do 8 of these for the board, and it took me about 6 hours to create the template, file the brass splines to shape, and sand and polish them. I sanded each outward facing edge from 120 to 600 grit, then took them over to this new buffing wheel I got. Buffing is actually pretty new to me, but I found a great video discussing the basics of buffing from Maverick Abrasives, which influenced me to purchase these compound bars from them. These are actually not the bars they recommend for brass, but the video wasn't as clear on brass polishing, so I followed the recommendations for aluminum since it's another kind of soft metal. The brown bar I was using is their Tripoli T88, and the green is called Green Rouge G16. Once those were finished, I installed them. I labeled each corner of the board, as most of them had to be minorly adjusted for their specific slot. Then I masked off the wood with some automotive high performance 233 plus masking tape. I'll link that below, and that's going to keep the wood clean from epoxy. After those were fully set, I covered them in that green masking tape as a protective barrier before we move on to the fun, but also pretty scary part. That being cutting the boards in half. This is kind of scary for a couple of reasons. One of them being safety, as this is kind of an awkward cut, but I've also put a lot of effort into what I'm cutting up right now, and if it were to say kick back, this would be an absolute slap in the face, both metaphorically and potentially physically. That's why I made this tall fence, so I'd have better support up high. This also made the cut more accurate, but regardless, I still wound up needing to come back and flatten the board halves. You saw how I dropped the blade down to cut only halfway through the material on the 3rd and 4th pass. This is paramount for both safety and accuracy. Otherwise, the pieces will be unsupported and you'll wind up with a kickback or simply some really deep blade marks that will probably ruin the project. Unfortunately, I couldn't get that cut accurate enough to have the board halves come together seamlessly, so I set up my homemade slab flattening jig to get those dead flat. On the brass board, the flattening process gave me a little tear out here, which could have been sanded out, but doing so would have made the corner really ugly, so I tried doing a little walnut patch. This didn't turn out all that great though, so later on in the video I wound up routing out some handholds, which completely removed this deformity. Next, I used the brass I'd be using for the trim as a setup block to cut a dado in the top and bottom panels. I set the blade depth just a little bit lower than the full depth of the metal, as I was wanting this trim to sit a bit proud of the rest of the board. To attach the panels into their frame, I used a slower curing epoxy from Total Boat to give me more working time. This is their 5:1 epoxy resin with the fast hardener. It was sent to me by mistake while ordering their high performance epoxy, but because it contains certain chemicals, it couldn't be returned, so I wound up getting it for free. For my time using it, it works great as an adhesive where it won't be seen, but it has a yellow tint when cured that their high performance epoxy does not. That being said, I've filled knots with it with a black pigment and the yellow is not visible, so it's worked for my needs so far. Now let's take a look at more suffering as the result of using this stupid veneered plywood. There was a small scratch here that I wanted to sand out, and as I was doing that, I accidentally sanded through the veneer. At this point, it was too late to go and redo the entire panel unless I wanted to start the whole board over from scratch, but I couldn't in good conscience just leave this. So I committed to the repair with a walnut patch by routing out this section. Anyone who's done any amount of woodworking, or any project for that matter, knows that mistakes are often inevitable, but making the decision to fix them, no matter how small, always leads to a better end product. In my experience, these mistakes wind up accumulating to create more issues down the road. You saw how barely noticeable that sanded through spot was, and honestly, I heavily debated just leaving it. But throughout this project, I made a commitment to fix my mistakes, no matter how small, with one goal in mind: do the best job I possibly can. But even then, I wasn't super happy with how it turned out, so this became the designated bottom of the board. I will, however, confidently say I gave this my best effort and did not quit until I was satisfied I could not do a better job. Like I've already said, I tried this 3 times, each time meticulously selecting a piece of wood that best matched the grain pattern. I think what angered me most is that it probably would have looked better if I just left it, but I guess that's just another lesson learned from this project. Now I'm going to show you how I did this trim. Nothing too crazy, I just slightly modified my picture frame sled to have a fence that reaches all the way down. You can see those little wings I put on it there. With each of these pieces, I snuck up on the correct fit until everything fit nicely. One thing that was kind of annoying about fitting these was I couldn't put them all in at the same time. I learned this the hard way by almost getting them stuck in the grooves and had to dig them out, which almost caused me to slip and dig my prying tool into the veneered board. Once they were fitting correctly, I used a little flathead screwdriver to etch a number into the backside of each piece in order to keep track of which goes where. Then, I attached them to a flat board with some double-sided tape and got to sanding. I'm using some Windex as a lubricant, as I've been led to believe wet sanding is a superior method of sanding metal. It clears the metal dust and allows the sandpaper to remove material more efficiently. And once those were sanded nicely, I buffed them on the wheel like I had with the brass splines. Here, I'm cleaning the pieces with acetone. Then I attach them with the same epoxy I used to attach the panels to the frame. Again, it's important to be pretty conservative here. You don't want any squeeze out if you can help it. Now we're onto the hardware installation. I picked up these 10mm hidden barrel hinges from Rockler because I thought they looked really cool, but quickly found myself worried about how I was going to install them. The specifications are quite precise, not something easily done without a jig of some kind. So I hopped into Fusion 360 and created a little spacer block with 2 holes in it for the center punch. As I've gotten more comfortable with 3D modeling, I've found more and more uses for my 3D printer. And what might surprise you is that these machines can actually be quite cheap. I have an Elegoo Neptune 4 Plus I got on Facebook Marketplace for only $200. Without getting into the details, I can tell you it's got all of the modern features you'd want in a 3D printer. What's really cool about 3D printing is that you can get machine level precision on a budget. Yes, there's a bit of a learning curve and sometimes these cheaper printers can be a bit finicky, but once you get the fundamentals down, it's pretty smooth sailing. I've been thinking about doing a video on 3D printing for woodworking. It would probably be a demo showing how to create a basic model, dialing in my print settings, and discussing issues I've had with my specific model of printer and how I've overcome those. If there's any interest, please let me know in the comments, particularly things you'd like to see in such a video. Back to what I'm currently working on here, it's important to use the actual millimeter drill bit size that's listed for these barrel hinges. I had to order a 10mm brad point bit specifically for this installation, but even then, these hinges fit and they're pretty tight, so I had to lightly knock them in with a mallet and screwdriver. For this cherry and maple board, I used some 3/8" magnets to hold it closed. These are pretty easy to install. I just lightly sanded the back and glued them in with some 5-minute epoxy. However, I totally forgot to account for the magnet's polarity and wound up having to literally drill out that magnet to fix the issue. It looked pretty nasty right after doing that drilling, but it was nothing a little light sanding couldn't fix. For the Padauk and maple board, I used those same barrel hinges, but the metal made it a fair amount heavier, so I decided to add a third hinge in the middle. I installed the outermost 2 hinges first, but because the board halves were now assembled, I no longer had the reach on my drill press for that middle hinge, so I had to make a little guide block to drill those holes. I wasn't a huge fan of the magnets on the other board, so for this one I ordered a little swing latch. I really wanted these to be solid brass so I could polish them the same way I did for the rest of the board, but everywhere I looked online only sold this kind of latch as brass plated. I ordered 2 just in case I needed another and tried buffing on the wheel, but that latch wound up looking silver, so I needed another approach. Instead, I just used a little bit of Flitz metal polish, doing this by hand to ensure I didn't go through the plating. Sourcing the hardware I thought would look best for this project required a fairly extensive search process, so if you have a resource for something like this in solid brass, I'd love for you to share it below. Here, I'm just showing you how I route out the handholds. I used this jig from John's Custom Woodworking. He advertises it as a cutting board handle template, but I found it useful for a number of projects. It's a little pricey, but it works really well, and I'll link to this template and his demo video below. Routing these handholds was how I eliminated that deformity I'd showed you earlier in the video, and now it just looks like this was planned from the start. To make the custom checkers, I needed some kind of CNC machine. Thankfully, my buddy Ron has a shaper and was able to get this done for me. He used the shaper to cut a deeper circle for the perimeter and some smaller circles to create a cool little pattern. Then he ran it through his bandsaw to cut them out. I met Ron while working at Rockler. He's a really stand-up guy and great woodworker. This was also a great opportunity to get to see his shop for the first time, experiment with the shaper a bit, and just get to catch up. Ron, if you're watching this, I'm still waiting for you to come down so I can show you how I get my miters so perfect. You're the man, and thanks so much for helping me out here. I didn't show this earlier, but I also put an 1/8" roundover on all the board edges, except the ones where the boards would meet. You might have already noticed, but putting finish on these boards was not done at the very end like you might do with other projects. There were just more convenient times to apply finish, and the product I was using was really easy to resand and refinish if that was necessary. I used Osmo 3043 hard wax oil for everything in this project because I really like the look. I've watched a lot of videos on hard wax oils, and every time I've seen this product, I've loved it. The only problem with this finish is that it seems to be less resistant to water damage, as opposed to Rubio Monocoat, which is funny to me since this was originally designed for hardwood floors. However, this is a backgammon board that's just supposed to look nice, and I'm guessing most people won't be using it as a coaster. Anyways, let's see the final product. Well, that's it. I mentioned this at the start, but the Padauk maple and brass board is up on my Etsy. I realize $1,000 is not cheap, but this board took me over 46 hours. I actually kept track, and I poured my blood, sweat, and tears into it. That being said, I have my Etsy set where you can actually make me offers if you feel like the price is too high. I hope you enjoyed taking part in the process, and if you liked the video or have any input, please don't forget to like, subscribe, or comment, as that is the main way the algorithm knows to recommend this video to others. Not to mention, if you saw some ads throughout, I am not yet monetized. I recently realized YouTube still will play ads on a non-monetized channel, which I think is a little whack, but I kind of get it since the video takes up server space on their end. Anyways, thanks again for watching and have a good one.